So we've got an engine in the car and it's still in there, it hasn't fallen out, so we must have engineered the mounting system properly. It's all bolted up, ready to go. I don't think we're going to take it out again, we're just going to leave it in there for good now. It's a bit of a nugget to get in and out, so we don't really want to have to do that if it isn't required. What we did gloss over is that we've added these bars in here, which are factory things that it basically pulls a tension on this big cross member assembly, because it's actually rubber mounted at the top, so this stabilises the position. It's got adjustment on it, you can actually roll the cross member back and forward. I'm not sure whether that's supposed to be to change the camber or the caster or whatever, but we just sort of set it up so it's in the middle and tighten it all up. It does stiffen it up quite a bit. Everything else is pretty happy. We just got to start working on the exhaust in inlet manifolds. I'm going to get Matt to come and have a little squiz and do some measuring and for the inlet manifold, and we'll just have to custom make it using that BA lower runner section from the older BA model engine. So he's going to come around later tonight after work and we'll have a quick squiz at it and he'll work some magic. I've had the tail shaft made in the meantime. As soon as we got the engine in there in the right place, I just measured it up and got straight onto the tail shaft shop. It's not very long and it's got a slip joint in it because the ZF box has got a tripod outlet that usually has a rubber donut on it, which you basically don't use because they're junk. Sometimes called a guibo, which is a funny name. But anyway, the tail shaft shop has these made by a CNC guy to adapt it over to a normal uni. I think it's a 1330 or something unis, something big. So you can see it looks like a simple thing, but they've actually put those lugs in it which actually sit inside here, so it's got a good drive on it with it, and it's not just the bolt holding it on, so it's pretty fancy. On the other side it's got the 4-bolt uni assembly, and here is the tail shaft. So it's a big unit, it's got a big slip joint in it. These are solid universal joints. They don't have you can't grease them after they've been fitted because they don't have, they're not drilled through for the grease to travel through because that weakens them. So they're called solid cross unis, both ends. It's got a slip joint in it, of course, because there's no slip joint in the back of the gearbox. So that sort of definitely brings the price up. It's always something to consider if you've got a gearbox like that your tail shaft is not going to be as cheap as a normal tail shaft to go in the back of a Turbo 400 or something, because they have a slip joint as part of the output. So when the diff goes up and down, and the tail shaft length changes, you've got to account for that in the assembly. So that's what that does on this particular shaft. So as I said, not very long. That's good. Usually means they're less prone to failure. No one likes tail shaft failure, do they? Bear lane. So I think today we're just going to have a fiddle with the fuel tank. We've got a bunch of parts have turned up since we've started doing this. Millsy's been smashing the company credit card pretty hard, just ordering whatever I tell him to. So we've got a Aeromotive Phantom assembly to go down inside the fuel tank. So we cut a hole in the top of the tank, it drops in there, pumps mounted on it, basically converts your old fuel tank for the old carby car into a sort of surge protected electronic injection tank. So it's a pretty cool thing. So we'll get into that in a bit and we'll talk about it in more in depth. I've got a set of big brakes for the front, disc brakes. So don't panic, we are putting disc brakes on it. We are putting disc brakes on the rear as well, but that won't be done until the diff gets rebuilt, because it's got a new set of diff gears for it, and like a short track centre and everything. But with these GM diffs, you can't just pull the axles out easily. It's sort of like a major job to dismantle things, because the axles are clipped in from inside the back of the housing. So I'm not going to go to all that trouble to fit the disc brakes on it when it's only going to get pulled apart again by the diff guy. So we'll just connect everything up, and the diff guy can then fit the rear disc brakes later. So they'll probably all be Falcon-based brakes. It just makes it easier for engineering, and it's good enough to stop almost stop a Falcon. They're not the best in the world, but this car's also lighter, so obviously a lot better than drum brakes. So let's get stuck into the fuel tank.
Hey Al, the internet says you don't like Hondas.
I do like them if they're gurney.
The fuel tank is covered in 38 years of schmutz, so Al gives it a clean up with the gurney.
Bit cleaner than the foul lane, eh?
Hope so. I don't think we'll be able to buy an aftermarket tank for this.
Sweet Challenger, dude.
This is not a sweet Challenger. This is Woody's Challenger. So what we're doing here is I'm not adding an extra muffler to muffle out the horrible V6 noise this thing makes. I'm actually purging out the fuel tank using the gas that comes out of the engine exhaust as an inert gas. So even though we've drained the tank, there is still vapours in it, and vapours is what's going to cause you problems. It's the most probably the best mixture of fuel to ignite if you start messing around with a fuel tank. That said, you shouldn't mess around with fuel tanks unless you are a professional and you are experienced and you know what you're doing. So don't just, because you see me cutting up fuel tanks and putting pumps in them and stuff, don't think that you can just go and do that yourself and it's not dangerous. It is dangerous. You've got to take precautions and you need to know what they are and how to do it. I'm not going to tell you because I'm not going to be responsible for you doing stupid stuff. I was taught by Old Cock, who's been cleaning fuel tanks and modifying them for forever. That's why I'm confident to do it myself. Don't do it. Watch, learn, get a professional to do it. Don't blame me if something goes wrong.
So how long do you leave that for?
An hour or so.
Sweet.
Yeah. Puts a bit of heat in there. Basically removes any of the vapours, so you can get vapours caught in the seams and stuff like that, and that can cause problems. We're not going to weld the tank or anything, but just cutting it is, it's just a precaution. Get rid of everything, and it also allows you to clean it out properly as well. Get rid of all the old dirty fuel and that sort of thing. Then we can retrieve all the things that have fallen inside the fuel tank over the years, like combs and false eyeballs and stuff like that you normally find inside fuel tanks. While we're waiting, coming in, I'll show you about the fuel sender. Here's the old sender. This pipe that used to be that pickup won't be used anymore. We'll probably just cut that off and seal it up. The Aeromotive Phantom has got its own, all the piping is all included in it, even the vent, so we don't need any of that stuff. It saves you capping it off, which looks ugly. While it's out, we may as well just solder the end up. So what I'm going to do here is test the resistance of the fuel sender, because what we're going to do in this car is Millsy's chosen to use an aftermarket dash that just runs off the engine control unit. So any information that dash can display, including things like fuel level, has to go through the engine computer. And so we need to know what the empty and full resistances are, because that's basically all it does. It's just a wound resistor inside there that this wipes on. So we check it, that's its low point. So we'll wander around a bit. And then we'll do it at the high point. So we'll call it 33 ohms and I think 1.5.
The good old trusty multimeter works well, doesn't it?
The multimeter works fine. It's the dirty old Bedford sender that's probably not the greatest. You wonder why you run out of fuel, Millsy. Anyway, we got that data. So you're probably not going to be surprised that we're going to use a Haltech plug-in ECU on this vehicle. It's a new product that's just recently been released. It allows you to basically unplug your Ford ECU out of your XR6 Turbo or whatever and plug the Haltech in, and then you've got fully tunable ECU that you can tune without having to flash tune it, which is quite time consuming. It's also got a 36-pin connector on the back of it, like one of the old Haltech, what the Haltech normal ECU uses, and that gives you a bunch of auxiliary inputs and outputs that you can do whatever you like with. We will put this fuel sender unit into one of those inputs, and then it will then output to on the OBD, on the CAN, to the dash that we're going to use. We'll also put a wideband. It's got an inbuilt wideband in it, the LSU 4.9, which is new. They used to use LSU 4.2, and I assume that the 0.7 is better. So when we get the ECU, we're going to wire all that up. Not only are they great plug-in product for your BA Falcon, BF Falcon, whatever, the other good thing about them is that it saves you a lot of hassle with security systems and stuff like that. So you don't have to disable the security when you put the engines into a different car, which is a lot of conversions going on because they are a great engine. Put them into all sorts of cars, from Skylines to Patrols to everywhere in between. So especially when you've got one of these late model engines, like this engine's only a few years old, so it's not as easy to get rid of the security systems on the newer engines because they keep changing stuff all the time, and someone has to basically hack into the ECU to find where the security coding is and a method of disabling it. So it gets annoying for me as a guy fitting the engines to have to do that, because I can't do that myself. So the Haltech ECU gives us the opportunity to just bypass all that, and also has the benefit of being a fully tunable ECU. It will also run the ZF 6-speed automatic, which is awesome. Heaps of advantages. So we're looking forward to getting hold of that. It'll be on its way soon, and we will wire that up further down the track and talk more about it then. I was giving it about an hour running. The car's probably burnt through a quarter of a tank of fuel and half a sump full of oil. That's just normal ratio. So it runs a bit like a two-stroke. So the tank's all good. No, that's not fuel. It's just schmutz out of the back of Rodriguez's car. We're ready to start having a look at the tank to see where we're going to put this pump. The top of this tank is a pain in the ass because it's got big whoops in it because we need a reasonably flat surface to mount the pump unit in. It is built to handle this sort of ridge in it, but it's better to find a place that doesn't have it if you can find it. A lot of tanks are built like this just for the strength purposes, although they've conveniently made it flat on the bottom where I can't put it. Thanks, Bedford. This is our pump unit. So it's basically uses a bit of fuel-proof foam as a surge tank with this sort of rubber bit on the bottom. That's your pump hanger, and it's basically just got to find a spot for it, cut a hole, drill a bunch of holes. That unit goes up from underneath, which then clamps this down. So it's got a foam seal, and that seal can take up sort of some of these sort of ribs. It can only do it at a certain amount though, so as I said, better to try and find a spot where it doesn't have ribs if you can. So we'll have a look. You've also got to look inside the tank and make sure you're not going to put it anywhere where there's already, say, the fuel sender or anything like that. So you're not clashing with other things. So you've got to get a torch and have a look inside. Look, sometimes they've got pipes running inside that do vapor control and that sort of thing. So make sure you have a look first and follow the instructions, of course.
Any valve stems in there, bro? Valve stem seals from the Challenger?
It doesn't have any. How could there be any in there? It's actually super clean in there. It's amazing. Actually looks like we'll be all right here. That section there is wide enough to house the unit. So we pretty much just got to find out which spot we want it. We'll also have to have a look at the car itself, because where these rubber pads are, there's actually some sort of cross beams, support beams for the tank in there. So we have to obviously make the pump where it sticks out the top not interfere with anything else in the car, and also have a place for the lines to go once they come out of the pump.
Nilsy won't mind if we just cut a hole in the floor though, would he?
You probably wouldn't. We've done enough of it already.
Looks like quite a fair bit of room up in there between those rails, eh?
Yeah, should be fine. Sort of want to position it around about here somewhere, and we can run our lines out over the top of this little channel, because they've got to go to that side of the car anyway to go into the fuel rail. Shout out to Dave.
Didn't you say to be careful of return lines and stuff in there, huh?
Yeah, but I got nothing. No, we just have to move it out of the way. Doesn't need it anymore. There's a rock or something in there rolling around. I don't want to do a blare and get my hand stuck in it. You do it.
Oh, that's pretty sharp, bro. What the hell is that?
The hell is that? It's like a 8-ball gear knob.
Period correct for the Bedford.
Milzy.
Don't f it up.
Shut up.
Using the template provided in the kit, holes are drilled through the tank for the studs to go through. Al gives it a little clean up and then gives me the task of cleaning out all the swarf that fell inside.
Woody got his arm in there and cleaned out all the swarf and he's up to about here, which is pretty normal for him. There was a fair bit in there, but he used a combination of vacuum cleaner, rag and magnets to get all the metal swarf out, so she's all clean now. Tank is in remarkably good condition for its age. The next thing we've got to do is fit this and then cut down that to size. So what you do is measure it. So it's 200 deep. So they say to add another inch. So 225 is the height of this. So we'll cut this down at 225 and then it basically gets stuffed inside the fuel tank. This knife's pretty much here for this purpose. It's just a bread knife. You'll see I've rounded off the edges side to side. That's just because we're very close to these rib lines. I don't want it to either stop it from pulling up hard or sort of puncture a hole in the tank. So
You like my hat, Al?
no. This template now comes back into play. It's actually used as sort of a funnel to stuff that thing down inside the tank. So we got to use it again.
Going in dry Al and no lube.
Yeah. So the sock bit's in there. It's you pull it out and it comes back around the like the C-shaped ring and holds itself up against the outside of the tank. So that's sort of your surge tank of sorts. That's its function. One thing I don't like too much about them is that they always seem to do that. That's just how they are. So what I do is get a piece of 4-inch stainless cut about that far, like 2 inches, and then cut a C into it and squash it down in there and then spread it back out again, and it sort of holds a bit more tension on that foam to push it out of the way. Probably doesn't need to be like that, but I just can't help. It just annoys me, so I do it. The other relevance of our 200mm measurement is to cut this bracket down. So it's sort of multi-purpose. It can obviously go from, I think it goes from 300mm to 150 is the shortest height. That's why you cut the foam. In some applications you might not cut that foam at all. And same with this bracket, but we're going to cut it off there. So it's about 190mm, so it's just off the bottom of the tank. And that's obviously your pump support. It goes up against that. This tube is your pressure hose. You obviously cut that down to whatever appropriate size is. So we'll do that, and I'll go and cut a piece of stainless to shove in the bottom there as well.
like that.
Yep, that's straightened her out good.
With the bracket cut to size, Ella fits up the Bosch 400 litre per hour fuel pump.
No zip ties, Alan.
It's not a Sylvia.
All finished, Al.
Yep. So as you saw me with the soldering iron, don't get used to it because it's not going to happen very often. So I just desoldered the wires because this plug is completely different. You can't, and joining them, the only way you can really join these things is with crimp terminals, which sucks. So I just heat them up and pull them out, pop them back in with the new wires, done. It's basically doing exactly the same thing as what they've originally designed, just changing the wires. So she's all ready to go in. That's the sealing ring, so that's going to go on first. Then the pump. And I'm still debating which way I face it. I'm going to have to go that way. Just to give ourselves a bit of room for the actual fittings, because there is a bulkhead sort of thing here, but we will just drill a few holes in to let the lines run through, but we need a bit of room for the fittings to actually come out. That might be even better, so we can just come around. She's in there ready to go. All we need to do now is cut off this and solder it up, and then work out our fuel plumbing. So obviously ins and outs before the tank goes back in, and probably just run a wire tag down into a plug so we can actually access the connector rather than having to get above it, screw it on, and then place the tank in. So we'll just leave this for the moment. I'll get a new O-ring for that as well. She'll be back together and we'll be ready to put it back in then. And then we'll move on to one of the other 1,000 things that needs to be done. Matt's come around after work because he's got nothing better to do and he really loves the Bedford. None of that's true. So he's going to have a look at this inlet manifold situation. We're going to have to make it, obviously. So Matt's got a bit of a sketch here that he reckons is going to work. So I'll let him explain it.
Just going to try and adapt a lot of the original design of the manifold, but we need to make it fit underneath the floor, so it's just been cut down. We'll just bring it down, plant them underneath the floor, and yeah, everything's have to be directed down because there's just no room with the chassis rail, so something similar to this, with similar volume, straight down, out of an elbow and back towards intercooler.
Sounds sweet.
All right, I'll get onto it, eh?
Sweet, thanks mate.
Catch you later.
See you, dude.
See you, man.
Millsy is making me use up all my Matthew credits on his van, and that's not cool, Millsy. God damn it.
You struggling now? You look tired, dude.
It's either tiredness or it's just all the schmutz from the floor falling in my eyeballs all the time. Anyway, hopefully Matt will come up with something pretty soon and we'll be able to move on, get this sorted, get that side sorted, get this side sorted. Might have a usable vehicle one day, sort of usable.
I did. Ready for a test fit?
Yeah. Okay. Cool.
Okay, so first test fit, we're still pretty close to the floor, so there's two things we're going to have to do. We're going to have to take more of the floor out. We'll have to probably just rotate the inner plenum flange a little bit so we can actually point it sort of more in a downwards direction to get away from the floor, so we're not having to cut so much of the floor out.
Take it out to about there, and that'll give us the
Yeah.
the actual clearance that we need.
Yeah.
So Matt's going to do his thing with that. I think we're just going to go with what we've got and just make the floor fit, because otherwise we're just chasing our tails. I'm going to cut the floor out some more tomorrow, and then we'll retry it once Matt's got that tack back together in its full form. But for today we've had enough. There's only so much Bedford you can handle in one day, and I'm done.